Okay, so this is the mock paper question 2, and this deals with Hooke's law, which is all to do with the extension of a spring under a load from a range of masses. This is a specified practical, so it's very likely to be a question on this in your exam in the summer, much like question 1, which is also a specified practical. So it says the diagram shows a spring being stretched by adding masses. The spring is stretched within its elastic limit. What that means is it behaves in a predictable way. Okay, so the more mass you add, the extension is predictable. Part of the method used for investigating the extension of the spring is shown below. So the first thing to do is to record the original length of the spring. Okay, so with the ruler, how long is the spring without any masses on it? That's the original length. Then it says suspend the spring from the clamp and attach the 100-gram mass hanger. So there's the clamp, and then the mass hanger is the hook with no other weights on it apart from the base, and that weighs 100 grams on its own. Okay, and then we've got a gap, and we need to fill that gap. Possibly the more sensible sentence to put in that gap is sentence B at the bottom here, which says record the new length of the spring. Okay, so if we put the letter B there, and then it says add a further 100 grams to the spring and record the new length. So you've added 200 grams now because you've started off with the original mass hanger. You've added an extra 100 grams and you record the new length. And then the next thing to do from our list down here is probably going to be C. Repeat step 4 until a total mass of 700 grams has been added. Okay, so you keep going around 4 and 5 until you've added 700 grams. Okay, so that's going to be another 600 gram masses on top of the original hanger. Then it says remove all the masses and repeat steps 1 to 5 once more. So you're going to do the whole experiment again to get some repeat readings. Okay, and then the last 2 steps here, the 7th step is going to be calculate the mean length for each mass added. Okay, so how long is the spring over your 2 readings? Okay, so that would be A. And then finally, calculate the mean extension for each mass added. That means how much longer did the spring get from its original length. So the very first thing you did was to record the original length of the spring. So you take that away from the mean lengths that you calculated in step 7, and that gives you the extension. Okay, so that's letter D. Now, next question, quite difficult. One source of inaccuracy in this experiment is measuring the length of the spring. State 2 ways this measurement could be improved. Okay, so one method would be to ensure a precise ruler. That means one with millimeters on it, so that you are measuring as precisely as possible. You must ensure that the spring is stationary when you're measuring. It's not bouncing up and down. An additional one, as you can choose 2 of the 3, was to remove what's known as parallax error. Okay, so if we go back to the picture, okay, if you were to view this experiment, so this is the physics picture for an eye. There's an eye there, okay. So if you are looking at the, I'll tell you what, no, we'll draw the eye a bit lower down because it doesn't quite make sense there. Let's draw it here. Here's our eye. If you're looking at a funny angle, you're looking up at the extension and you're reading your ruler here, okay, and that's inaccurate. You need to make sure your eye is level with what you're reading so that you're reading the ruler accurately. So you can see there's a big difference between these 2 measurements here because you're looking from the wrong angle. you need to be horizontal with what you're measuring. Okay, so that's called parallax error. You need to avoid that. You need to make sure that you get your eye level with the end of the spring, as level with the ruler. If you're looking down or up, you get an inaccurate reading. Okay, so this next question says, the spring has an extension of 8 centimeters when a mass of 400 grams is suspended from it. State the weight of the 400 gram mass. So here you've got to remember that mass is a measure of how much stuff we find in an object, whereas weight is a measure of how Earth's gravity affects that stuff. So what it's telling us here is that 100 gram weighs 1 Newton. So mass and weight are different, okay? Even though in our day-to-day lives we tend to use those two words interchangeably, but in physics they are different. So if 100 grams weighs 1 Newton, 400 grams must weigh 4 newtons. Okay, so the weight of 400 grams is 4 newtons. Now use the equation. The spring constant is weight divided by extension to calculate the spring constant for an extension of 8 centimeters. Okay, so we want to know the spring constant, which is often given the letter K. And we're told here to divide the weight by the extension. Okay, now what we've got to remember here is in the previous part of the question, and this happens a lot in physics in all exam papers, you're given information that you need to use here. So the weight, okay, so it tells us here about the mass, and we're asked to work out the weight. So the weight previously calculated is 4 newtons, and the extension mentioned here is 8 centimeters. Okay, so 4 divided by 8 is 0.5. Okay, so 0.5 newtons per centimeter. Okay, now we need to remember that two things. First of all, as is mentioned in the first part of the question, this experiment is within the elastic limit, and as we mentioned previously, that means that the spring behaves in a very predictable way, and the way it behaves is defined by the spring constant. Okay, so for every half a newton, then you get a centimeter of extension. Okay, so John says the mass of 200 grams would stretch the spring by 2 centimeters. Explain whether his claim is correct. Okay, now if we use our spring constant, okay, then we rearrange our equation here, right, so that we know what the extension is, okay, then we can see that extension is the weight divided by K. And we know what K is because that's 0.5. And the weight for this particular part of the question would be 2 newtons. Okay, so the extension is 2 newtons divided by 0.5, and that's in newtons per centimeter. Okay, so 2 divided by 0.5 is 4, okay, which is 4 centimeters. So the extension is 4 centimeters. Okay, so that's using the spring constant and the mass turned into a weight found in the question. So we can see that John is incorrect. So John is incorrect. The extension would be 4 centimeters. Okay, now you can get the marks for this by not doing that calculation. It is sort of intuitive. You can use comparisons between this question and the suggestion there, and you would still get the 2 marks. Okay, so the first mark is for saying he's incorrect, and the second mark is for giving the reason why he's incorrect.